This is lesson 95 in Saxon's 3rd edition Algebra 1 book, and this lesson is about graphs of nonlinear functions. Now we've been dealing with graphing and graphing lines and finding the slope of a line and that kind of thing. When you have a line, that is a linear function. That's what that means. Linear means line. Nonlinear means exactly what it says. It is not a line. And there are 4 different types of functions that we have that we're going to discuss in this lesson. And I have them pictured here for you. We've got absolute value functions, and it's always going to look like this, like a V. It may sometimes be upside down, but we'll have some more examples of that later. This is called a quadratic function. Quadratic means that x is going to be something squared. And this is called a parabola when it's in this like U shape, and it may be going up, it may be going down, it may even be going sideways, but it's still called a parabola. Alright, and then we have a square root function. So which is dealing with a square root of x, or x to the 1/2, as you'll learn in your next book. And it's going to look kind of like a shooting star, and like an arrow, okay? And then you have a cubic function, which means that x is going to be cubed. And it looks sort of like this crooked little S. So let's take a little closer look at each one of these one by one. Quadratic functions, like I said, there's different ways you can do a quadratic function, and the quadratic equation, which we're going to be learning about in several lessons now. But ax plus bx plus ax squared, plus bx plus c is kind of the quadratic formula that we're going to be looking at. And you see that in this first term, the x is squared. So when you have that, that means it's going to be a quadratic. And this is letting us know a is either greater than 0 or a is less than 0. And all of these are examples, picture examples of a quadratic function. And you can see it looks like a U or an upside down U. Sort of like if it's upside down like this, kind of looks like a hill. Alright, cubic functions, the first term, the x is cubed. Now see this, if we had just this much, the bx squared plus 6 plus d, that would be a quadratic function. But when you add in this other term, and it's the first term and the x is cubed, then it's going to be a cubed function. And generally speaking, the graph of a cubic function is shaped kind of like a sideways S. Or like in this case, it kind of looks like a wave frequency, as we've studied in science. Alright, so these are just different graphs of what a cubic function could look like. Most of them in your book right now are just going to look like this. Okay? Square root function, the function of x equals the square root of x. So you're always going to see a square root for x in these. And again, this is, like I said, it just looks like a line that somebody started and whoop, they just kind of went off with. And here it's got the arrow, so that's why I say it sort of looks a little bit like a shooting star. But that's the square root. That's what it will always look like, a line like this. Alright, and then finally the absolute value function, which means that x is going to be in an absolute value notation. So that's how you can tell those. You can see that this one looks like a V, this looks like a V. this looks like an upside down V, but not even a complete V. We know that if this line extended on out, this would go down like this and would be a V. So those are the four nonlinear functions that we're talking about in this lesson that this book is mainly going to be concerned with. So this lesson is really mainly a matter of telling these four functions apart, which one is which, as you'll see when we get to your practice problems here in a minute. I would like for you to put in your notebooks to draw the shape and write beside it either absolute value or the equation, knowing that how to match and how to pick these out. So let's do some practice problems now. Alright, so this is the kind of problem that you're going to have in your lesson sets. A says given are the equations of four functions. And shown below are four shapes. For each shape, identify which function has a graph that most resembles that particular shape. So what we're going to do is look at what we know here in these equations. Like for instance, we might be looking for, the first one has x squared. Well, we know that if the x is squared in the first term, then that is going to be a quadratic function, and a quadratic function is this number 4. It looks like the U. So we would put by number 4, A, number 1, 2, 3, and 4. By number 4, we would put the function of x equals x squared plus 2. Alright, and then the second one is an absolute value function, and that is the one that's going to be the V shape. So number 3, the g of x, or function of x, equals negative absolute value of x minus 1. Okay, and then we've got the cubic function. You can see the x cubed there. Do you remember which one I said is going to look like the cubic function? Hopefully you do. And that would be the number 2. That looks like the h of x, or again function of x, equals x cubed plus 1. And finally, then we can, by a process of elimination, the k of x, or function of x, equals the square root of x. So this little shooting star thing, that is a square root function. Alright, and then B, the same thing. It says shown below are four shapes. Match to each shape the function defined below whose graph most closely resembles the specified shape. So in B, number 1 is the parabola. We know that is the quadratic. So we look down there and see which one is the quadratic. Well, that is this last one right here, because that x is going to be squared. So let's just say by this one I'm going to put number 1. And then number 2 is going to be the square root. So that is this. Number 3 is the absolute value. So that's going to be this first one here. And then number 4 is the cubic function. So that's number 4. So match those up in your notes the best way you can. And I will see you next time for lesson 96.